Hi students, coming to the next topic in the compiler design, that is the loop optimization. So in the previous video I explained about the code optimization techniques. Now let's see what is this loop optimization. Okay, so the loop optimization, it is the most valuable machine independent optimization. So we will say the loop optimization is the most valuable machine independent optimization because the program's inner loop takes bulk to time of a programmer. So if we decrease the number of instructions in an inner loop, then the running time of program may be improved. Obviously, if you increase the number of steps in the inner loop, suppose here the loop is there, if you reduce the instructions inside the loop, then the running time of the program may be improved, even if you increase the amount of code outside that loop. The one thing you have to remember, when you're writing the programs, if you're writing the programs, try to reduce the statements inside the loop. If you want, you can add those statements, unwanted statements inside the loop and write it in outside the loop. Always the running time of program may be improved. Okay, suppose if even if we increase the amount of code outside that loop, so how we can increase the amount of code outside that loop? If you replace the statements, if you return the statements outside the loop, because the loop is always rotating until the instruction is exit, until the condition is not true, it is going to be continue the loop. So every time the unwanted statements are reading, so it's better if reading one time is less than the reading of more times, right? So it's better to write the unwanted statements outside the loop. Then it will the running time of program will be improved. So that thing you have to be remember. That is the main concept of the loop optimization. I'm going to optimize the loop. How I'm going to optimize the loop? I'm just removing the unwanted statements and placing those statements outside the loop. Let's see. The loop optimization is having three techniques. What are the three techniques that are important for the loop optimization? One is code motion, induction variable elimination, and the strength reduction. So actually these three concepts we discussed in these are the techniques of the code optimization itself, but we are talking about the loop optimization. So the loop optimization has to take care about what code motion, induction variable elimination, and the strength reductions. So with the help of these three techniques, the loop is going to be optimized. Now let's see. So already I discussed, and again I want to take some more examples to explain the code motion and the induction variable elimination and the strength reductions. Okay, so don't be confused. Whenever you asked about the loop optimization, you can write these three techniques, and if they are asked about what is a code optimization, try to write these things because everything is the same. Okay, so here I'm going to explain in brief. Code motion. It is used to decrease the amount of code in the loop. The main thing of code optimization is going to decrease the amount of code inside the loop. This transformation takes a statement or expression which can be moved outside the loop body without affecting the semantics of the program. If you want to move the statements outside the body, you have to make sure that the semantics of the program is not going to be changed. Okay, without affecting the semantics of the program, you are moving the statements from inside the body to outside the body. Let's see the example. So here, while I is less than or equal to limit -2, the statement does not change limit. So after code motion, the result is I'm just placing a is equal to limit -2 and I'm writing while I is less than or equal to a. Means I'm going to assign this statement to a outside the loop. Okay, and I am using only the a. Instead of writing every time, instead of reading the compiler every time limit -2, I'm just taking it as a variable a. So it is going to reduce the code, reduce the amount of code in the loop. So this is a code motion. In this while statement, the limit -2 equation is a loop invariant equation. Okay, now coming to the second one, induction variable elimination. So it is used to replace the variables from inner loop. So induction variable elimination, it's discussed about the inner loop, the loop inside another loop. It can reduce the number of additions in a loop. It improves both code space and runtime program. So here I have written two inner loops. This is a block 1, block 2, block 3. Inside the block there is block 2. Inside the block 2 there is block 3. Inside the block 3 there is block 4 and block 5. Like that. So these are the inner loops. So here you can see here the considering the loop around the block 2. Considering a loop around the block 2. And here whatever the T4 I am taking is decreased by 4. It is going to decreased by the 4. So after reduction, so this is the before and after induction variable elimination, this will be the code. So why I have written this? Because this is a 4 into j. Instead of taking the star means multiplication, I want to make it as an addition. I am going to reduce the multiplication to addition. Okay, how it is possible? So here T4 is decreased by 4 because 4 into j is assigned to T4. Such identifiers are called as an induction variables. We call these type of variables as an induction variables. When there are 2 or more induction variables in a loop, let's take suppose there are 2 or more induction variables. These type of induction variables are present. If 2 or more induction variables in a loop, it may be possible to get rid of all by the process of induction variable elimination. So for inner loop around B2, we cannot get rid of either J, and T4 completely. So whereas the T4 is used in B2 because the T4 is already used in the B2 and J in B3, and here we are used in the J in the B3. So however we can illustrate reduction in strength and part of process of induction variable elimination. So eventually the J will be eliminated when the outer loop of B1 and the B5 is considered. So when this J will be eliminated, when we consider the outer loop of B1 and B5. So just instead of replacing this, reducing the operator strength with the help of this induction variable elimination. Now coming to the third one, what is the third technique in the loop optimization? Reduction in strength. The strength reduction is used to replace the expensive operation by the cheaper ones on the target machine. So addition of a constant is cheaper than a multiplication. So we know that the addition of constants is cheaper than the multiplication. So we can replace the multiplication with addition. So wherever the multiplication is there, just replace the multiplication with addition within the loop. Multiplication is cheaper than exponent. So we can replace the exponent with multiplication. So always the exponent is greater than the multiplication is greater than the addition. So whenever there is a higher operator, just replace the higher operator with the lower operator. That is a reduction in the strength. So let me show you the simple example here. Here this is before strength reduction. While I less than 10, j is equal to 3 into I plus 1, a of j is equal to a of j minus 2 and I is equal to I plus 2. So this is a loop. So I want to, whatever the code that is inside the invariant code, that should be written outside, and I want to replace the higher operator with the less operator. Though then the strength will be reduction. So after the strength reduction, the code will be, I had taken one variable s is equal to 3 into I plus 1. So because I just taken this out, it is an assignment operator, so it's better to write outside, so that the while every time the while is not supposed to read this statement. Now j is equal to s, I assign the s value to j and I call these equations s plus 6. So in the above code, it is cheaper to compute s is equal to s plus 6 than j is equal to 3 into I. So these are the different techniques of the loop optimization. Okay, code motion, reduction in the strength, and this the induction variable elimination. Thank you.